Ready? Thanks, Chris. I already know a lot of you here in this room, but for those that don't, my name is John Barentine, and I represent this fine organization, which is the world's largest NGO that's dedicated to preserving the nighttime environment. And we do that through the promotion of quality lighting, which is something that at first to some people seems sort of contradictory, that why are we trying to save dark skies by promoting lighting? But it's with the belief that humanity has very legitimate needs for nighttime lighting for different reasons, and we're not going to win this fight by simply telling the world to turn its lights off. So what I'm here to tell you about is something that a lot of people in the astronomy community don't know very much about, and that's a program that we have that's called the Fixture Seal of Approval. And what this is predicated on is the belief that if we go out to communities and to homeowners and business owners and all of these different figures, and we tell them, here are all the benefits to having good quality lighting that will improve dark skies, that because we think these arguments are so compelling that one way or another we're going to get through to them, they're going to say, great, I'm on board. Tell me where I can get that kind of lighting. And up until when we started this program, we kind of just said, well, you can go to Home Depot and see what they've got on the shelf. But there's not a lot of information on the packaging that will tell you what kind of lighting you're buying. Until recently, they didn't have to state things like the color temperature of that lighting packaging. Thanks to working with the Department of Energy, we've now got that at least on the boxes. But the idea here is what the little subtitle is connecting consumers and lighting solutions. So this is what I was talking about, how this fits within the scope of our mission, and I've highlighted the important words in this, which is the through environmentally responsible lighting part. So our goal was to get with the manufacturing community, try to articulate what we believe to be that responsible lighting in an environmental sense, and then to encourage them to produce it, to create the market demand for this kind of lighting so that they would see that it would be a profitable enterprise, and it's not just about, we're not coming to turn the lights off or put you out of business. We're trying to find a way to keep you in business in a way that kind of gets everybody what they want out of the deal. So that's where the program ultimately comes from. Fundamentally, there are only 3 specific items in the list of requirements for lighting in order to qualify for inclusion in the program. And they are that, number 1, the lighting has to be fully shielded. It has to have, if you're familiar with the so-called bug rating system, it has to have a U0 rating, which means no uplight, because we know that that light that comes out at very shallow upward angles is just about the worst that you can get. So, there are variations on this. You can control kind of what's in that first few degrees down from the horizontal, but fundamentally we say it has to be fully shielded, 0% uplight. We have a restriction on the correlated color temperature of that lighting, which is currently set at 3,000 Kelvin. We have been ramping that down over time. It was previously set at 4,000 Kelvin until the end of 2014. Look for that to change yet again, because every additional piece of evidence that we get about blue light, both in terms of its impact to sky glow as well as its ecological impacts, says that blue light is bad and we need to do everything we can to try to eliminate it from our environment. And third, the hardware that is involved in mounting the lighting cannot be user adjustable. And I'm particularly looking at examples like this for what we call knuckle mounts, which allow you to vary the angle of the lighting. You can see some fabulous examples of terrible lighting here in Grapevine. No offense to the host community, but I'm seeing a lot of this sort of thing around here. These lights, even if they met, if they were designed to be fully shielded if mounted horizontally, and they had the right color temperature, the adjustable mounts would disqualify them. So the manufacturers submit evidence that they've met these requirements. They have to have their photometry testing done by accredited labs. They have to submit certain reports to us that establish those things. And if they do that and they pay the registration fee, we will give them the right to use this service mark on their packaging. And you can literally walk into a retailer like Home Depot or Lowe's. You can pull a box off the shelf. You can look for the IDA label. And if that's on there, you know that it meets those criteria. And this has slowly become a desirable element of the sales of these companies. This is something that they want increasingly. And now we have several dozen manufacturers and close to 1,000 products, I believe, in the database. Speaking of which, I didn't want to do a live demonstration because that always goes terribly. If you go to www.darksky.org/FSA, you will see this page that will help you find this kind of lighting. And you can search by a variety of different things, by the company, the manufacturer, the application. You can search by the retailer to help find these specific products. So, as an example, I picked area lighting. And right away, you're starting to see pictures of products. And if you click on any of those particular records, in turn, it will give you more information. There are links to data sheets that are on our website, links to the manufacturer. We're still working on trying to figure out how to connect up the consumers with the manufacturers through the retailers. That's something that has been more difficult than we expected, because people say, all right, I want a link on your website to where I can go buy this right now. And that turns out to be a fairly complicated thing if you're a nonprofit. So, because we don't do any of the sales, we're just trying to get people to the people who do actually do the sales part. Strengths and challenges of this program. We have brought manufacturers to the table. The fact that there is 3,000 Kelvin and below core temperature lighting has a lot to do, I think, with this program and promoting this. If we hadn't been putting it on their radar, I don't think that the manufacturers would have sensed that there was any sort of a market demand for this. As I said, it's become a sought-after market distinction. The number of companies that are participating in this is steadily increasing over time, and that we have helped create a market for the low color temperature white LED products. And in the belief that LED is the future and it is here to stay, we felt that the best we could do in terms of trying to get the better products on the market, this was going to do the best for trying to accomplish our mission. On the other hand, we have a number of challenges associated with running this program. The flood of cheap goods coming from countries like China is not doing us any good right now, as you might imagine, the least of which is intellectual property theft. But besides that, those companies don't see a value in a program like this because they're in volume and trying to sell at the lowest possible price, and we're probably not ever going to get them on board. We need to come up with a different way of characterizing the blue content of lamps besides correlated color temperature. I could talk to you for an hour about why color temperature is not a good metric, and my friend over here could tell you a lot more about that than I know. That's something that's on our radar and we're working on right now. As I said, better connecting consumers with retailers and anticipating new technologies. And that's the thing I hope we get to towards the end of the session today is we were caught by surprise really by how rapidly LED proliferated. And before whatever the successor technology begins to take hold, we need to be on the forefront of that. And so that is already on our minds. So I will leave you with this again. So when your elected officials, when your homeowners association, when your school board, when any of these outfits comes to you and says, we get it, we want to be part of this revolution, where can we get good lighting? You show them that, and that will take them to where they can find it. And so if you have any questions about the program, the contents, please feel free to talk to me sometime today. Thanks, Scott.
So next on the hit list is Dan McKenna. And Dan has an interesting way of measuring it. This is going to be a new device that he would like to talk to you about.
Thank you, Maestro. So back around 2008, in collaboration with the IDA and Barentine Observatory, we developed what we call the Night Sky Brightness Monitor, or NSBM. The goal for this development of the photometer was to build a photometer that would be stable over decades and would be well characterized. During the development, the company known as Unihedron, which makes these sky quality monitors now ubiquitous, contacted me and asked me if they could copy my design, and asked me questions about calibration and all those other things. So I agreed to help them because I knew once the detector filter technology was accepted, quickly this photometric system would have the largest database ever, and it has. So this is the detector head consisting of a very simple optical system. What we wanted to do is make sure that it was stable over decades and had stable characteristics. Here is some data. Here is, notice for you astronomers, I am giving you sky brightness in right ascension and declination. I'm not doing it, I have a time series, but these are all the same places in the sky because I have about a 0.1 radian, 5.76 degrees beam width. Now, here's moon set here. There's a little bit of moon. Notice the modes we have. We have these lower levels where they all seem to congregate and one lower, and then several up much higher. And if we zoom into the next one, yes, here once again in ours right ascension, and the detector has an output frequency which is linearly proportional to brightness. So notice these things coming through. The last thing we saw around in the beginning was the galactic plane. These are other areas which contain features that we can see. So here's the darkest sky, and there are the brightest skies. These are all with no moon. So what we're seeing is when the fog covers up San Diego and LA and everything else, that's our darkest sky, and it's a few percentage brighter than the darkest sky we've been able to measure with the IDA program when we had the data. And then here's the brightest sky, and that's when the inversion layer is above the observatory. So that's dust storms and things like that. So that's astronomically a half a magnitude of variation. So you must understand the atmosphere. Now here's the interesting thing. When you make a photometer, how do you say, well, you know, we understand the calibration over long periods of time? So recently it became available the 1 billion object catalog, the Gaia catalog, and I just said, well, hey, I'll just take strips of sky to go by my photometer. I will convolve it with the beam pattern, and so you see the galactic plane coming through and a hump and dropping down, and that's calculated based upon the Gaia catalog. And here's what's observed. So this is a fit by eye just to show that we can do it. And it's a 2-parameter fit, the scale factor and the sky brightness. So we think by using this technique in a dark sky, we can have very good calibration over long periods of time. Okay, so we have this car-mounted spectrometer. I suggest everybody has one. This is the spectrum of San Diego as viewed from Carlsbad. That's a combination of discharge lamps and some LEDs. And here's a high-pressure sodium spectrum. So what we do is we go around and we catalog all the different light sources. And then when we observe a sky spectra, we combine the catalog in order to get a light inventory. Here's the spectral response of the night sky brightness monitor. It peaks in the visual covering the scotopic and the photopic, and it drops off. It covers the blue spike, which is here, and the cutoff was designed so that the photometer would respond less to sky glow, which is not man-made. So what we're trying to do now is we're trying to look at a typical LED spectra and then find out what combination of standard astronomical filters, if used to create a multi-channel instrument, would give us this blue index of the skylight so that we can monitor the evolution of the sky brightness. So our goals are to refine the use of the Gaia catalog, measure sky spectrum from Palomar, and with catalog, estimate light inventory, modify the current photometer to include standard astronomical filters, refine the photometer point spread, function, calibration, and pointing, because most people just take their sky brightness meter and point it and go, well, that's what it is. I say, where is it relative to the natural brightness variations of the sky? And then finally, For unlike the one we developed for IDA, we want to use open source hardware, software, publish all our secrets, and make the design available to all. Okay, so I talk about the necessity to, as some said, to encourage ownership, to engage in teamwork, broaden our horizons. So go team, go. Thanks for being here.
Thanks, Dan.
Thank you, Chris.
I'll get into some of the technical aspects of very basic light pollution control or dark sky preservation strategies. I think the IAU 2011 in Beijing was probably the most succinct message for all of us. Yeah, three priorities for dark sky preservation. Shield it. Get rid of the high angle light. That lumen at 91 degrees is 40 times worse than that lumen going straight up at the zenith. So shield number one. Once you've managed shielding, then we can talk about other things like spectral content, total lumen emissions. But yeah, we've got to get this out of our society, and Chilean society, and Asian society. This is 1940s, 1950s mindsets, where you put up the biggest baddest light you can find. These are 1,000-watt floodlights. Aim them in the general direction of where you want some light, and by accident, some of it actually gets where you need it. The rest of it is just wasted light into the sky, and dithering into nothingness. It never really hits where it's supposed to be going towards. Based upon real-world applications, we can replace a 1,000-watt floodlight, HID floodlight, with 220 watts of LED now. Fully shielded, and the light is going where we want on the ground. So 80% energy savings, without even trying hard. That's where we are right now. This is a mine site I worked on in Nevada. This is one of those 1,000-watt floodlights, 10 feet off the ground, aimed parallel to the ground. They were trying to light this pond some 50 yards away, even though the pond's in shadow due to this berm here. It's just, somebody said, hey, put some light on the pond. The electrician said, okay, I only want to do this once. So we got a 1,000-watt floodlight, mounted it on the side of the building, 10 feet off the ground, said, boss, I'm done. Well, if you're walking towards the light, you can't see anything because of the disability glare. As time went on, they finally figured out that, well, here we're trying to light some air conditioning equipment here. Let's just put some small wattage fixtures on the wall, and let's tip them down 45 degrees. Again, they have the floodlight mentality. They don't have the fully shielded optical performance mindset. And then here's the phase that we got involved with, which was replacing 1,000-watt floodlight aimed parallel to the ground, replace 250-watt floodlight aimed 45 degrees down with a 30-watt LED fully shielded to light the entry doors and this equipment pad. That's a transformer right there. When it comes to lighting, glare is never good. Glare is unsafe. It doesn't help you see, makes you squint, ruins your adaptation. So all of these mantras that, more lighting is more safe are totally fallacious. We don't need floodlights anymore. This is a sports field 15 miles from the Smithsonian Observatory south of Tucson. 2 soccer fields side by side, fully shielded LED optics, to where we stopped at this facility on our bus tour after the IDA meeting. About 2 miles from the site, I started talking to people. Said, okay, let me know when you see the field as we come up to it on the bus, right? So everybody's looking. You usually can see a sports field from miles away because it's floodlights aimed like the first slide I showed you. This one, I think the bus was probably about right here. And, you know, the lights came on because we were at the field. Would you agree, Jeff?
Yes, so I was on that bus, and we were absolutely floored. You have to go stand under this to appreciate what they achieved. It is magnificent.
So this shows that you can have a environmentally and astronomically, and more importantly, neighbor-friendly. There's a 4,000 home retirement community across the street from this facility. I was more worried about them than I was the MMT. But I knew if I took care of the neighbors, I would take care of the MMT. So here's your solution for your Chilean sports parks. There's no reason for them to use 50, 60-year technology to light their soccer fields. Again, LED, instant on, instant off. These are on a control system where the coach, if it's rained out that night, the coach makes a phone call, the lights never come on that night. The coach can also make a call, turn one field off if that gets washed out. They can turn the lights off between games. With the old systems, with the restrike time, you just left it on from dusk to 10 or dusk to 11, whenever it timed out. We have the instant on, instant off capability of LED that we never had before. Plus dimming. Here's a photo of Tucson from the MMT. And this is a microcosm of the floodlighting replacement we did at Tucson International Airport. These were, again, 1,000-watt high-pressure sodium floodlights tipped up, installed in 1985, 4,400 watts per pole. We replaced them with 220-watt LEDs, 4 per pole. So that turned into this. The person taking the after photo had to call me and say, where was I aimed again? I can't find the airfield. It said, look for the neon control tower, right? But that's, this is a 15-mile away shot. And that's how dramatic the change can be, going from unshielded garbage floodlights to modern LED optics with asymmetrical performance. The Tucson airport is easily the easiest airport to park your plane at, and that you're not driving into a face full of floodlights anymore. So here we'll talk about spectra. After we get the shielding under control, we can then talk about spectra. The regulation of spectra does vary greatly. Some places we talk about color temperature. Other places we talk about actual spectral content performance. 15% sub 500 in Chile, I think it's 15. That might be wrong, that might be 25% in the Canary Islands, below 550.
Could you go back, Chris, and explain in a little more detail what you mean by those limits?
Yeah, the spectral graphs will actually show that a little better.
Okay.
There's a better metric out there that we like to work towards, which is known as the scotopic-photopic ratio, which is part of any IES lab report. As we're discovering, though, there are many different action spectra when it comes to light sources. People are promoting SP ratio as one metric. They're promoting melanopic action spectra as another metric based upon circadian response in the human eye, the non-visual cells. You're talking about photosynthetic action spectrum. You know, how do you not affect plants, or how do you make plants grow fast? Why do people want to grow plants fast these days, right? Biggest growing industry in the country, agricultural lighting, horticultural lighting. And there's salmon action spectra for fish. So all kinds of different organisms have different response curves, and we can measure all of these different metrics. There's your blue peak. Okay, that's something like this right here. Everybody like blue headlights? Nobody likes blue headlights. Why would you make your people work under blue headlights? Why would you make your people drive under blue headlights if nobody likes the blue headlight spectrum? That's almost 10,000 Kelvin. I actually measured that though. This is actually 12,000 Kelvin. Very blue. Here's our warm white 3000 K. Actually, let's look at this SP number here. 2.5 scotopic to photopic. The higher the number, the more it scatters in the atmosphere, the more glare component it has. 3000 K, half the SP ratio. Look at this blue content here. This is about, if you integrate all of the energy here, that's about 15% of the entire spectral output. Here's a filtered LED. This is why color temperature is not a good metric. SP ratio is even better than 3000K, but it's over 3100K CCT. This is one of the graphs that, that Dan showed that was measured in Hemet. 2000K unfiltered. This is brand new, came out of the lab October 15th. And this is what 2000K looks like. Superficially, it looks like high pressure sodium, but it's full color rendering, over 80 CRI, and it's about 100 lumens per watt. And as I said, fully dimmable. This is dimmed by 90%, just with two little wires, a gray and a purple wire.
And the blue's only about 4%?
4% sub 500. So the industry is being very responsive to these concerns, mostly for lay people. Lay people don't like this, just like astronomers don't like this, but for different reasons. Nobody likes glare. So why do we make people live under it? There's the narrowband amber. We're working with Jeff and Chris Lugenbiel to implement in Flagstaff. 0.3 SP ratio. Very, very low, very little scattering component, very good for astronomy. Not only being its narrow wavelength, but blue scatters less in the atmosphere, as we all know.
The cosmos.
Very energy inefficient. About 25% of the energy efficiency of 3000K LED. But energy isn't the only concern in any locale. In some places, it's a lower priority, much lower priority. Given the prevalence of the observatory so close to Flagstaff and in some cases in the middle of town, the sacrifice for energy is deemed to be worthwhile to protect the astronomical interest. However, as Jeff said, the city is interested in changing the lighting to something that's less monochromatic, to where there's at least some color rendition. Because in some studies, driver reaction time is enhanced by some color rendition. So here we're proposing the 80% narrowband amber and a little bit of 2700K, which manifests itself in this little bump over here and a little extra energy in the green spectrum. But this ends up bringing that light source up to an approximation of high pressure sodium, just a little bit worse than HPS. But that's something that we hope to have in the demonstration project here in the next few months up for everybody to see in Flagstaff. So those are the various spectral options available in the marketplace, from 3000K all the way to ambers, PC ambers, filters, and now 2000K out in the lab, full color rendering, and a great one-for-one replacement for HPS in a spot replacement basis. If the whole city can't replace all their lights at one time, they could put that in as each HPS fixture fails. I think that'd be a hell of a demonstration for La Serena. And that fixture is actually built to do that. You take the guts out, bolt that up in.
We went a tiny bit longer, but I don't know, that was impressive. Thank you very, very much. I didn't want to stop yet. We do have something now, and I have to ask, I have to beg the audience attention on this. If you can't hear the audio, I'll just stop it. We're trying to, we tested it, and we think it works, but this man has a wonderful Texan drawl, and I don't understand Texan drawl sometimes, so.
No, this is easy.
Okay. Do you want to, we'll start the, before you do that, let's start the PowerPoint together. So he couldn't be with us, but he did this wonderful interview with the National NPR basically, very kind of recently, like maybe, was it half a year ago or so? And it just tells you, I'm taking a 7-minute segment out of the hour-long interview, just 7 minutes. And And it just tells you the status of where they're at. What's impressive is his understanding of the oil and gas industry, because in this particular instance, the problem is the flaring and other things. He doesn't really think the flaring is going to be a big problem, but other people do. And this is Bill Wren here, and this runs through automatically the whole PowerPoint, yeah, and it moves. And we can start the audio in here, how they're dealing with this. He does go into LEDs a bit, but it does give you a good flavor. It did.
Look at that.
This is West Texas Talk. I'm Mark Love. Our guest today is Bill Wren, Special Assistant to the Superintendent, University of Texas at Austin, McDonald Observatory. Good evening, Bill. Good evening. Among other things, Bill, you're in charge of the Dark Sky Initiative.
He had it set, but somehow it got disturbed.
We were able to take advantage of some of those funds and have paid the electricians to do the installation for these lighting retrofits at these different locations, so it didn't cost them anything. They got brand new state-of-the-art LED lighting, which is dark sky friendly, and they'll be saving a chunk of change on their electric bill. Because the LEDs are so much more cost efficient.
Happy the oil exploration.
You'll hear that?
Yes, they have. In fact, the industry is in the process of modernizing its lighting systems to LEDs.
It's coming from the
old
projector.
legacy style lighting.
It's just a projector only.
We tested it, so it's just being
It's cumbersome to move that stuff around in the oil field. Of course, that's the exploration side, which is mobile, we're constantly moving around through drilling rigs and completion operations and stuff like that. But there is a whole production side that wants to do with the product, wants to get it out of the ground. So they build permanent installations, gas processing plants, and other permanent installations where they even there, it's interesting, is the LED, assuming that the fixture has been designed so that it's shielded in such a way the light doesn't go into the sky and it gets installed properly and not aimed up at high angles. So a lot of the times, what we see in the oil field are these huge areas like, something the size of an oil pad, about 1 acre of ground or more, that they try to light up the whole area with just a light, one or two lights from a very low height. So they aim the fixture sideways, and that shines basically half the light that goes up into the sky. Only about half of it makes it to the ground where they want it. So we're trying to come up with ways that they can light their activities. And the LED is a big part of it. There's a company in San Antonio, Pioneer Energy Services. It's probably been the leader in working with, they work with us directly and working with other companies that are their partners to use lighting. But the LED, they're very excited about the transition to the LED technology because the fixtures are much smaller and more lightweight. They don't have to worry about workers getting their fingers crushed when they're moving the drilling rig from one location to another by these big heavy light fixtures. They're solid state. What the LED is a solid state circuit that emits light, and it's very durable. It withstands a lot of abuse, which you find out in the oil field where conditions are pretty rough. And so the maintenance cost is much lower. Power consumption is maybe 20% or so, 15-20% of what the legacy forms of lighting were. So they're not burning as much fuel, which may not seem like because they've got these big generators going there to operate these drilling rigs. But I've seen them kind of do the math in their heads, thinking it through. Well, we don't have to. If we're only drawing 20% of the wattage we used to, then that's less fuel that we have to haul in to run the generators, which means we don't have to maintain the LED is inherently blue, and the manufacturing process has gotten to the point where now they can make a much more efficient warm white, what they refer to as warm white, so lower color temperature LED. It's more like an incandescent bulb than the bright blue headlights you see on the highway. You know, it's much more, it's much easier on the eye at night. So it's actually, it reduces glare. Yeah, that's another thing. Is the glare is reduced by shielding the fixtures. Visibility is enhanced on the work site, and workman safety is increased. So there are lots of reasons why the oil industry is modernizing to the LED.
Well, with that, we're out of time here, Bill. My hat's off to you. You got quite a challenge there to keep the skies dark around the observatory with this natural oil mine on time. I know you've had success with that industry, and hopefully that cooperation will continue.
All right, Mark, I really appreciate it. And I've got one other thing. One of the major concerns we have is while we believe we're working successfully with the oil and gas industry itself, we're also concerned about all the commerce that comes along with it, all the new motels and chain stores and restaurants. And
Truck shops.
these counties can help a great deal by notifying businesses that come into the area, the counties and the cities like Reeves County and the city of Valparaiso, for example. They're pertinent right now with this badge fine. The people who are moving into the area to build a new restaurant or motel are informed that there is an outdoor lighting ordinance to protect the skies from the observatory, and that they should light the facility accordingly. It's all in writing. It's just a matter of notifying people. We strongly believe that education and awareness is the key to this thing. We don't want to go the enforcement route. We just want people to adopt the lighting because it's better lighting for their purposes.
Yeah, so local governments should, they don't have those codes in their building construction overplan.
Right. When somebody applies for a permit, would be a good example. It's just the question is there a mechanism in place in Reeves County, for example, if somebody wants to build something, do they have some kind of mechanism by which they can include a notification about the lighting ordinance? Because the lighting ordinances themselves have no notification laws. They post it in the newspaper a month after they've been adopted or something like that, but that's it. So the counties and the cities with these lighting ordinances can help us.
That was good work.
Is everybody awake now? There's a planned thing. Okay, so you can see, not only does he have this knowledge of how to work with the industry, because he understands them and what their needs are. That's very, very important if we're going to progress. But he also is forward thinking and thinking what the next set of problems are going to be, namely the commercialization that's going to be brought into the community. It's starting all over again? Maybe not. But yeah, so I just wanted, that's another level, or not another level, but another type of problem that's occurring with respect to the astronomical field, and something to keep, aware of. And either talking with Bill, I'm sure he would welcome emails, or just following, he's always in the paper. So following his progress would be great if it's applicable, especially to your needs. So that's all I wanted to go over with you guys.
And since Bill did that interview, he actually publicized the magnitude of the findings within the Permian Basin, and the oil within the shale structures within the Permian Basin exceeds all of that in Saudi Arabia. So, the Permian Basin will be developed. The McDonald Observatory is not moving. And we have this narrow slice of time right now to educate all these oil field operators. They would love to, they don't need any more nasty phone calls from bureaucrats. They would love to put in dark sky friendly lighting if they knew what it was. And to that end, the Permian Basin Petroleum Association, PBPA, with Bill's assistance and mine, is developing a master lighting guideline so that as their operators move into the field doing exploration and doing production, they'll have a design guide, probably include IDA FSA fixtures, to where they're all working from the same Bible, if you will. And we should be so lucky that Bill Wren's biggest issues are flares and not Blue Ridge LED floodlights. But Bill would love to be worried about flares. Yeah, he's looking down the road and says, well, geez, what do you do about the flares? Well, Bill, let's take care of the stuff we can control first. But anyway, yeah, Bill's a wonderful person. Here's your classic grassroots guy out there putting up, Hubble sky caps for the last 20 years, and I'm sure you know him well.
Yep.
Yeah. Bill's, he's a dark sky defender. He's got a resume this long of IDA accolades, but West Texas has long been on the radar screen for IDA and vice versa. It's really been a great educational experience for everybody involved. And that, the flea that roared, that is IDA sitting on the elephant of the lighting industry, has actually done something very, very productive over the last 28 years. And it comes in stages, but every time we make a move, it's been pretty momentous. And we're in the midst of another momentous time right now.
So it would be really nice if we could get the three of you up there just for, maybe 10, 15 minutes at most to answer any questions people have. And then we'd like to open it up to everybody being, all the panelists being up there for, a discussion of where we're going from here, and any questions people have.
I do have one thought to share on the question about national regulations or legislation. The U.S. military has what's known as the Unified Design Guide, or UFC, Uniform Facilities Guidelines. And for over a decade now, the military